Here's the solution for day 1, problem 1. Rewrite the number into standard form. So to do this, we use the exponent on the 10, which is positive 4, to move that decimal point 4 spots to the right. That's going to create 5, and then 3, 4, 0, 0, then the decimal point, so 53,400. Okay, question B. Take this number, 3,725,000, and write it in scientific notation. To do that, we're going to take the decimal point, which is at the end of the number, and move it here so that only the 3 is to the left of that dot. That will create 3.725. Then we can disregard the other 3 zeros, times 10, and 6 spots. The exponent on the 10 is a 6. Day 1, problem 2. Solve this equation, and then in part B, check the answer. So let's start by writing that equation down. And the variable n appears on both sides of the equation. Let's remove it from the right side using subtraction. 4n take away 4n cancels away. 6n take away 4n is 2n. Since we're collecting the n term on the left side of the equation, let's collect the constant on the right side. So let's remove this minus 1 by adding 1 to both sides of the equation. This negative 1 plus 1 cancels away. And over here, negative 5 plus 1 is negative 4. So 2n equals negative 4. How about 2 times negative 2 equals negative 4? I think that n is negative 2. In part B, we can check whether that's right. So go back to the original typed equation up here and replace the variable n with the number that we think is correct, negative 2. And we're wondering, does that equal this? Okay, on the left side, we need to evaluate this. 6 times negative 2 is negative 12. Take away 1 is negative 13. And on the right side, let's evaluate this expression. 4 times negative 2 is negative 8. Subtract 5 is also negative 13. These are equal, and so that answer checks.